Good evening, everyone. Welcome to the interactive session of Building Materials and Composites. So, in today's class, we will look into 10 questions. So, let's look one by one into the different questions that we have. Okay. So, this is the first question. What is the name of the unit used for building the roof shown in the picture? So, the right answer will be tile. So if we look into this particular building material, so this is the tile, and as we know that tile is basically a clay product. And what are the different other clay products that we know? So it includes firstly it includes brick. We have also seen about the terracotta tiles, and another one is the roof tile, which we see in this particular image. Let's move to our next question, which is cement is composed mainly of, and the correct answer will be oxides of calcium, silicon, and aluminium. Moving to our third question, the Eiffel Tower in Paris is primarily made of. The correct answer is iron. So if we look into the image of Eiffel Tower, so this is this in the right side of the screen we can see the image of the Eiffel Tower, and this Eiffel Tower is basically made of iron and not steel, and the puddle iron that makes up the Eiffel Tower structure came from the Pompeii forts, and the iron plates and beams that were produced through the puddling process were then pre-assembled in the Eiffel factories with the help of rivets. Now, if you look into this, there's something called puddling process. So, what is this puddling process all about? Basically, as we know that iron it can be of different types. For example, it can be pig iron, it can be cast iron, it can be wrought iron. So all these different types of iron are basically classified as per its purity, percentage of purity. And now coming to the puddling process. So puddling process is basically the conversion of any one type of iron into its higher grade of iron. This entire process is done in a furnace in the presence of some oxidizing substance. So that basically is what is known as the puddling process. Okay. Now moving to our next question. So here we have two statements. Statement 1 or statement P stating that particle boards are made from crushed stone, and the second statement, that is statement Q, it is saying that plywood is made from thin layers of wood. So we have to choose the appropriate option, where we have to select whether P is correct or P is wrong, whether Q is correct or Q is wrong. So if we look into all the options, we see that option C is correct. Statement P is wrong, but Q is correct, because particle boards are not made from crushed stone, whereas plywood is made from thin layers of wood. So let's see what these particle boards are. So particle boards, these are also known as chipboards, and or it is also known as the low density fiber board, and it's a type of an engineered wood product which is basically manufactured with the help of wood chips, and then the wood chips are binded together with the help of a synthetic resin or any other kind of binder, and then that wood chips and along with the binder is basically pressed and extruded, which gives the formation of this particle board. And if we look into the piles, this plywood is basically, it's made from thin layers of wood or piles of wood which are glued together, and then this plywood planks are basically prepared or manufactured. Okay, so let's move to our fifth question. If you look into the fifth question, we can see that what is the generic name of the construction tool in the picture below? So the answer is it's a chisel. And let's see what chisel is like chisel helps in doing. So if you look into this particular image that you see here, the first image to the left, if you see, so it's the chisel is basically chiseling out the wood. And if we look into the chisel as a whole, there are different parts of a chisel. For example, this upper portion, this is known as the steel hook. Then we have the ferrule, and then the neck portion is there, and this entire part from where you see the blade is basically just below the neck is the blade, and at just at the bottom we see bevel. So this entire blade can be of different types, and accordingly we see the different names of the chisel. For example, we see straight chisel where the blade is straight. We see straight corner where we see that the chisel has got a bevel at the end. Otherwise, the blade is like very similar to the straight chisel only. Then we have spoon chisel where the end is it is something very similar to that of a spoon, shape of a spoon. Then there are other different types of chisels as well. So these are not the only types of or classification of chisel. There can be several other classifications of chisel as well. Okay. So now moving on to our next question, question number 6. So what this question number 6 says, it says that you're asked to build a large auditorium for an institution. What are the properties would you consider in the materials chosen for construction? So for this particular answer, let's see. So the answers are the mechanical property and the acoustic property. Moving to our next question, bitumen may be produced by. So the answer is distillation of crude oil. So let us see what this bitumen is actually. So this bitumen basically looks something like this, and it's also known as asphalt. So it's a very as we can understand from the image itself, it's a sticky and black colored liquid which is produced through the fractional distillation of crude oil. And this particular product uh, can be is basically used to make roads. So this particular image shows the fractional distillation of crude oil. So if we see what fractional distillation of crude oil is, it's about the crude oil is basically heated at certain temperature, and with respect to the different temperatures at which this crude oil is being heated, uh, different forms of um, this crude oil we get through this distillation process. So this, if we look into this particular part, so if we heat the crude oil at a temperature around 350 degrees Celsius, so or greater than that, we get this particular product, byproduct, which is known as bitumen. Moving to our eighth question. So the eighth question says that plastering is a process adopted on the exposed surfaces of, and the answer will be brick masonry. So if you look into this particular image, you'll see that this image is basically that of how the plastering is being done. So as we can understand that the plaster is basically a thin layer of mortar which is applied over the masonry surface, so that is the brick masonry surface, and it acts as the damp proof coat as well, and as well as provides an aesthetic look over the brick masonry work. And when we say mortar, so mortar is basically composed of cement, sand, and water. So this is mortar. And so moving to our next question, choose the correct matching amongst the two columns. So on the on one side, that is on the left hand side, we have the material, ferrous metal, tile, wood, and cement. And on the right hand side, we have product, door, concrete, clay, reinforcement bars. So ferrous metal is nothing but iron, and or or which has or which has different or materials which are made from which has this iron element in it, Fe, and that is basically the reinforcement bar. So tile is once again it's a product of clay. Wood, door is made from wood. And if we see cement, so concrete is uh, produced with the help of, or basically made with the help of cement. So we have the option D as the correct answer, that is P4, Q3, R1, and S2. So coming to our last question, that is, for a certain grade of cement, the ratio of cement, sand, and aggregate is 1 is to 3 is to 6 by volume. And if 0.33 cubic meter of sand is used, what is the combined sum of the volumes of cement and aggregate? So we have to write our answer up to at least two places after the decimal point. So the answer is 0.7, the range is 0.7 to 0.8, but how do we calculate it? So let's see how to calculate this particular numerical. So it, what is it said is that cement, so 1 is to 3 is to 6 by volume. So one part is cement by it's by volume. Then one part of this concrete is sorry, three parts of this concrete is sand, and six parts of this concrete is aggregate or the coarse aggregate. What it says is that if 0.33 cubic meter of sand is used, so this three parts that we see here is basically corresponds to the 0.33 cubic centimeter. So if we consider X to be the total volume of concrete, therefore we can say that three parts of sand out of the entire part, that is 6, 1 plus 3 plus 6 of the total volume of concrete is equal to 0.33. Okay, so we have 3 by 10 x is equal to 0.33. So from here we can find x equal to 3.3 by 3, that is equal to 1.1 cubic meter. Okay, so if we calculate this, if we solve this equation, we'll find x equal to 1.1 cubic meter. So we have already found that x, that is the total volume of concrete, to be 1.1 cubic meter. So we have to find out what is the combined sum of the volumes of cement and aggregate, which means that what is the remaining part. So we already know that the volume of sand is how much? 0.33 cubic meter. Therefore, combined sum of the volumes of cement plus aggregate is equal to how much? 1.1 minus 0.33, and the answer will be 0.77 cubic meter. So the answer range is between 0.70 to 0.80. So this is what our final answer is. Okay. So thank you so much for attending this class.